Our homework from last night was page 681, number 1 to 3. We're going to go over number 2 and 3. In addition, we're going to go over our practice questions from Google Classroom after we're finished going over question 2 and 3. Okay, starting with number 2 on page 681, it says a 10.0 centimeter high candle is placed 100 centimeters from a diverging lens. This is the first thing that stands out to me, the fact that it's a diverging lens. Why? Why does that stand out to me? What do we got to make sure we do because it's a diverging lens? Yep, can we? Good. We're going to make the focal point negative. Don't forget to do that, because if you do, then everything is going to be messed up for this entire question. We want to find, forget about the ray diagram. We've drawn all of those already. We want to find the image location from the lens. That's the image distance and the image height as well as the type of image formed. So let's start writing down some givens here. We've got an object height of 10.0 centimeters. That's how high the candle is. It's placed 100 centimeters from the lens. That's going to be DO, the object distance, how far the object is away from the lens. And the focal length is, Kenway reminded me that it's going to be negative 25.0 centimeters, not 25 centimeters. Okay, that's critical. Everything in this question is wrong if you miss that negative. Let's find the image location, DI. Let's find the image height, HI, and then we'll find the type of image formed by something that we've already calculated. Let's use my lens equation for this. 1 over F is equal to 1 over DO plus 1 over DI. And let's sub some numbers in here. For the lens equation, you guys know me, the most equations that I use, I rearrange first and then plug numbers in. The exceptions to those are conservation of momentum. I usually leave conservation of momentum not rearranged. I plug my numbers in and then rearrange it. This is another exception. I usually plug my numbers in and then rearrange it after my numbers are in there for this one as well. 1 over negative 25 equals 1 over 100 plus 1 over DI. And some of you might remember the trick that I taught you on Friday. Negative 25, we got to take the inverse of that. So it's 1 over negative 25. And then we take the 1 over 100 over by subtracting. So it becomes minus 100, x to the minus 1, press equals. Now that's not DI, that's 1 over DI. If you want to find DI, you got to flip that over again. We end up getting negative 20. So there's my image distance, the answer to question A. My image height, we're going to say HI over HO equals negative DI over DO. That's the other equation, the magnification equation. HI is what we're looking for. HO is 10 centimeters. DI, oh, look at this. Careful with this one. Kayla, what are we going to have to put in here for this one? Yeah, it's going to be positive because it's negative 20, right? Divided by DO, which was 100. So I think when we solve for HI there, I think it works out to be just 2, doesn't it? And finally, question C, the type of image formed, real or virtual? Well, if we go back to our table, we know that we have a real image formed when we have a positive DI. What do we have here? It's a negative DI, right? Therefore, it's got to be what kind of image? It's a virtual image. Now, some of you may not have needed that sign convention in order to determine that. Some of you may have thought back to your ray diagrams. Every single time we drew a ray diagram for a diverging lens, every single time we got a virtual image. So if you remember that's great. You don't need to look at the sign convention. Okay? For me, I kind of forgot that. So I looked at this and said negative means it's a virtual image. Okay. All right, number 3. Says a projector uses a converging lens. Okay, this is good. It's converging lens. We don't need to worry about remembering whether it's positive or negative now because it's just positive. We leave it the way it is. Focused image on the screen located 5 meters away. The image is generated from a slide that's 7.5 centimeters. I want to circle this though. How come? Neither one of those units are bad, but what's the big but? They got to both be the same, right? So centimeters, meters doesn't matter, but make them both the same. What's the focal length? What's the magnification? I'm going to say DI is 500 centimeters. I'm going to make them both centimeters. DI is 5 meters or 500 centimeters because it says the image is formed on this screen. If the image is formed on this screen, that's going to be DI. And if it's formed on a screen, it's got to be a positive value as well because it's a real image formed on a screen. We're going to say DO, the object distance, that's the slide, distance from the slide to the lens, is going to be 7.50 centimeters. We want to find F and we want to find M. So 1 over F equal 1 over DO plus 1 over DI. 1 over F is equal to 1 over 7.5 plus 1 over 500. Say 7.5 x to the minus 1 plus 500 x to the minus 1. Is that my answer? Almost. What do I got to do with it? Flip it over, x to the minus 1, not x squared. X to the minus 1, there we go. 7.39, so focal length is 7.39 centimeters. Now M is going to be negative DI over DO. You can say HI over HO, but that's not going to be very helpful since we don't know what either HI or HO is. Negative DI, negative 500 over DO, which is 7.50. That gives us negative 66.7. Now we don't have to, no units there by the way, right? We don't have to identify characteristics of this, but if we did, we would know that it's really, really big, bigger than the object. We know that it's upside down because my magnification is negative. And we already know that it's real because it's projected onto a screen. They tell me that in the question. All right, the next thing that I want to do is take a quick look at the practice questions that we had from Google Classroom. Question number 1, as I said before, probably the most challenging practice question that or the most challenging diploma exam question that we've ever had on this topic, lenses. The math is ugly. It says at what distance above this page would a convex magnifying lens, at least it's a convex lens, which means it's converging. So at least F is positive. To give me something here at least. The focal length is 10 centimeters. We want the image to appear upright and 3 times as tall. We're going to say F is 10. We're going to say M is 3. And what are we looking for here? At what distance above the page would the lens need to be held? If the page is our object, if the page is what we're trying to magnify, and we want to find the distance from that page to the lens, then we're looking for DO here, right? That makes sense? Looking for DO. All right, we have 2 equations, so let's start off with the first one. 1 over F is equal to 1 over DO plus 1 over DI. You're going to find that it's not very helpful to me. Not yet, at least, because I've got 2 unknowns in there. So then we go to my second equation, which says M is equal to negative DI over DO. M is 3. Well, that doesn't seem very helpful to me either because I've got 2 unknowns there. What do you notice about the 2 unknowns that we have, though? They're the same as they were in the first equation. All right, think back to math, I don't know, 10, whenever you would have done systems of equations. 2 equations, 2 unknowns. Here's what I want to do here. I want to solve for DI. It's negative 3 DO. And then I want to sub in negative 3 DO for DI over here. Right, DI is negative 3 DO. So I replace it with negative 3 DO. At least in that first equation, now I have 1 unknown. It looks kind of ugly. Can't use a little trick of my calculator. I've got to know how to analyze fractions here for sure, but at least I've got 1 unknown. Find the common denominator, because that's how you add fractions, right? We're going to say 3 over 3 DO subtract 1 over 3DO. My common denominator here would be 3DO. So the first one is going to be, well, if it was 1 over DO, that's going to be 3 over 3 DO. And I made the second one, I just simplified it a little bit. The negative was on the bottom, but it doesn't matter where it is. When you're talking about a fraction, bottom, top, same difference. So now we've got 1 over 10 equals 2 over 3 DO, and now it becomes pretty straightforward, actually. We solve for DO here, and it ends up becoming 6.67 centimeters. So my answer would be B for this one. Number 2, an object is placed 35 centimeters from a diverging lens that has a focal length of 20. The image produced is, you could analyze this and solve for, DI, determine whether it's real or virtual, and then find the magnification, determine whether it's bigger or smaller. But I don't know about you guys, but I thought of the ray diagram for this. We have a diverging lens. My focal length is 20. My object distance is 35, so it's a bit bigger than the focal length. First ray, parallel, goes up away from the focal point. Second ray goes down through the center. My image is formed right here. It's going to be virtual and smaller. Right? How many people did this with the ray diagram? Okay, how many people did some math on it? Yeah, I usually actually tend to go with the math. I don't know why the ray diagram kind of appealed to me on this one. Doesn't matter. Okay, I think the math would have been more work for this one, but yeah, I'm getting the same answer as long as you can recognize the sign conventions. Logan, did you end up getting the same answer then? Okay, good.